All right, hello cross-country runners. This is 2-6. I'm going to give back quizzes tomorrow, so help me remember that after everybody is done with their quiz, hopefully. I'll give those back tomorrow. Solving systems of inequalities today, though, okay? So we've done already solving systems, but we did of equations, okay? So that looked like y equals 2x plus 3, and we're setting that up with, I don't know, 2x plus 6y equals 8. I have no idea. Something like that. And we would do those, and either by graphing or by doing substitution or elimination, we would find the place where those two cross each other, right? Doing something of that nature, and we're trying to find where those cross, okay? Now, sometimes you would end up with something where you would get like 0 equals 0. What does that mean? Infinitely many solutions are all reals. Infinitely many solutions. Let's go infinitely many solutions. And do you remember what that looked like if you were to graph those two? If it has infinitely many solutions, what does it look like? They're the same line on top of each other, right? Or sometimes you'll get like 0 equals 8, in which case you have no solutions. What does it look like then? They're two lines that are parallel. They don't touch. They're not going to intersect, right? Okay, so that's what we were doing when we were doing solving systems of equations, right? Now we're doing inequalities, and what's going to happen is when you draw a line, you're going to have it either solid or dotted, depending on if it's less than, greater than, or equal to, that type of thing. And then you're going to shade one side, but you're going to have two of them going on. So let's say I shade that side and shade that side. Now I have kind of like 4 sections of my graph. Do you see the 4 sections that are separated, right? I have this chunk right here, this one, this one, this one. Which one is the solution region? The top one, because it's double shaded, right? You see this one? He's shaded really dark. So that's what we're doing here. We're just graphing the two and finding that solution region, right? Okay. All right. So systems of inequalities, we have a feasible region. We have bounded and unbounded regions, okay? So like most of these are going to be unbounded regions. This one doesn't have a boundary, so it goes on forever up and up and up, right? But if we have a bounded region, usually we'll have to have like 3 equations for that. So let's say I have one going this way, one going this way, one going this way, and we're shading all of that in there. That's going to be a bounded region, right? So I have 3 equations or 4 or 5 equations where we have a boundary area, okay? All right, so that's that. That was a lot of things, okay? Unbounded region, here we go. I don't want to do that one though. Let's do, okay, I'm going to talk through this one and then maybe we'll do the check instead, okay? So this one is an unbounded region, kind of like what I just said. And they gave us the first one. They gave us y is less than 4x minus 3, okay? Y is, less than or equal to 4x minus 3. So if I go to graph that, I'm going to start at -3. And the slope is up 4 over 1. And it is a solid line, right? Okay, why is it a solid line looking at that thing? Equal to, okay, so it's a solid line, and then less than. So if I'm shading less than, I'm shading below, but which direction is below that line? It's, yeah, below on the y-axis, so it's going to be like the right side. So that's what we've shaded for that first one, okay? Now the second one, we have to do a little bit of work too, because I want to get y solved for. So how do I get y by itself? I heard Jay say it. Divide by -2. Did you? Yeah. Y is less than. Flip the sign. Okay. What's x over -2? -1/2 x. Okay. And then plus, what's this number right here? 0. Perfect. Okay. So I'm going to start at 0 and -1/2. 0 down 1 over 2. And I'm going to draw my dotted line. Why is he dotted? It's not equal to, okay? And then less than means we're going to shade lower than. Which region is double shaded? This one down here in this corner, right? That's the double shaded one, okay? All right? Happy with that? Let's do the check. Can we do the check real quick? This one's not too bad. Yes, sir.
How did you hear me?
I heard you. I could hear you.
I said that so quietly.
I heard you. I could hear you. Okay. All right, let's graph this first one. So go to where it says check so that we have one, like, I don't understand why when they graph it, they like graph it for you. So let's do the check one. We won't always do all of these, but we'll do the check one, okay? So if I graph this first one, where do you start? Start at 2, positive 2 right there. So put a dot on positive 2. And then the slope tells me 1, 3.
Up 1 over 3.
Up 1 over 3. Up 1 to the right 3?
Yep.
Because then he's going to go like this way, right? So before I connect the dots though, let's, is he a solid dot or a solid line or a dotted line? Solid, because he's equal to, right? Okay. So, and then I'm going to go down 1 over 3. So I'm going to connect, and that's my solid line. Yep. Yep. Okay, y is less than or equal to. So I'm going to shade lower than, right there like that. Okay? All right, ready for the middle one? Y is greater than x. But is that in slope-intercept form? Y equals mx plus b? It is? Yes, because y is solved for. But what's the b part? Plus what?
0.
0. Okay, what's the slope? What number's in front of x? 1, right? So we're just dissecting this, okay? So let's start at 0. 0. And then from there we go up 1 over 1. Up 1 over 1, up 1 over 1. Oh, I found where they intersected. There we go. Down 1, left 1. There he is. Solid line or dotted line? Dotted, because he's just greater than, right? So dotted line, dot, 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 dot. Okay, and we're shading greater than, which is above. He is above. Okay, and the last one. Ooh. Y is less than, I need to do another color. Less than or equal to 1.
So it's just across.
It's just going to be at 1, right?
No, left and right.
At 1, to the left and to the right. Is he a solid line or dotted line? Solid line. So he looks like this. Solid line. Okay? And he is shaded below. Okay, so what's my solution region?
It's super.
In between the blue and green.
Right here. This
Right
one.
there.
Can you see him? Can you see him like my black one?
Yep.
Okay? That's what he's shaded.
Be above. Oh no.
I want
No.
different colors.
Okay. Now, is this one bounded or unbounded? Unbounded. Unbounded, because he goes forever to the left side, right? What? Yeah?
Is
Yeah.
that what that means?
Yes. Unbounded means he has no boundaries. Like if I tried to fence in my cows with that, we would have a problem, right? Okay, now, if instead I was looking at this little chunk right here and shaded that region, would that be bounded or unbounded? That one would have boundaries, right? That would be a little fenced in area, yes?
It can be bounded even if it's like dotted line.
Yes, 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 yes.
But the fence.
Correct. Correct.
There's still-
Because that doesn't mean there's like holes in my fence. That just means like it's going up to that point but not on the line, right? Does that make sense? So it's touching like the 0.999 close to that line but not on the line, right? That doesn't mean there's holes in my fence. Okay, good question. I like that question.
Do you have different colored pens so I don't have to use these?
No, she doesn't.
Oh, no, I don't.
Why are you using
Oh.
I don't. Hey, look at you go. Okay, so there's that. Got it? Now, here's the question though. Here's the important part. Okay, somebody give me a dot that lives in this solution region. Pick one. Give me a coordinate. Negative 2, 0. I heard Trevin say. Hold on, right here. Negative 2, 0 is a point. That would work, right? Now, what this means, negative 2, 0, what this means is that I can plug in, let me erase. I can plug negative 2 in here and 0 in here. Negative 2 in here, 0 in here. Negative 2 in for x, which doesn't have 1, and 0 in there. And all of those will be true. Does that make sense? Any point that I have in that solution region, I can plug into all 3 of those there, and it will work. Does that make sense? So that's a kind of a way of going back and checking your answer if you want to. If you plug it in and it doesn't work for some reason in one of the equations, you don't have the right solution region. Make sense? Okay? All right, let's go to the next one. Example 2. This one is where he has a bounded region. So let's look and see how they graphed this one. They started there, that first one, at 5. Started right here at 5. And then we go down 4 over 3. Down 1, 2, 3, 4 over 1, 2, 3. And we have him right there. And he has a dotted line. Do you see why he's a dotted line? No equal to. And we've shaded below. So this guy is shading down here. Look at that mess that we have. Woo! Shaded below. Okay. Now this one. Y is greater than x minus 2. We start at -2, and
Up 1 over 1.
up 1 over 1. He is a solid line, and he is shaded above. So he's shaded up here. Okay, now I'm going to do a green one. And this one is x is greater than 1.
So it's a vertical line?
So he's over to 1 on the x-axis, vertical line, and shaded to the right. So which one is triply shaded? The little triangle in the middle that you can see, right? Little triangle in the middle. Okay? Do they ask for anything else? Solve the system of inequalities? Nope, that's it. Okay, give me a point that lives in that space.
2, 1.
2, 1. I like that one. That's like almost dead center. 2, 1. 2, 1 lives in there. So if I were to plug in 2, 1 in for all of these, it would be true, right? 2, 1 goes in there, and it is true. Good? All right. Let's do this one together. Check the graph the solution system.
I guess.
Okay, first one. Start at -3. And then we go
Up 4
up 4 over
over 5.
5. 1, 2, 3, 4, 5. Okay, you graph him also. Up 4 over 5 from -3. Is he going to be solid or dotted?
Solid.
Solid, because he's equal to.
Shade above.
All right, are you guys following along?
Yes.
Yep. Greater than, shaded above. Okay. The second one, starting at,
Not two.
shh,
Starting at 2.
shh, starting at 2. Mr. Sir that likes to do all these problems wrong. Are you listening to this? I did it this way, but I got the right answer.
What's wrong? If he got the right answer, what's the problem?
Because he works harder than when he has to.
I can't.
Sure. Okay, we're going to start the second one.
At 2.
At 2. Plus 2. From there, we go down 2 over 3. Okay, question. Down 2 over 3. Do we go 3 this way or 3 this way?
To the right.
This one or this one?
To the right.
To the right, because I want the slope to be
Down.
negative. So down 2 over 3. So I want it to be negative. All right, I'm going to get rid of my other dot. Is this solid or dotted? Dotted, because he's not equal to. So dotted line. Boop, 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 boop. And it's less than? So he's shaded below, underneath. Questions about the shading? You can stop me if you need to. All right, x is greater than 0. This one's confusing.
So it's
No, it's
on
not.
0?
It's on 0. And is it up and down
It's
or
down.
right?
It's up and down.
What if this said x is greater than 3? You would go to 3 on the x-axis and it would be
Up and down.
up and down. So let's go to 0 and he's going to be up and down. Is it solid or dotted?
Solid.
Oh, it's solid. Shoot, I made it dotted.
Then how do you?
Okay, like this, like that. And then we have greater than 0. So he's to the right. Numbers greater than 0 on the x are the numbers to the right. Does that make sense? X is greater than 0. X's are to the right, okay? So which region is triple shaded?
It's this little triangle.
This little triangle right here. So make sure you shade him in real dark.
21 had 42.
Okay, shh.
It's solid and
All right, good.
if it's just less than, it's just
Do you guys want to do the story problem or do you not want to do the story problem?
Is there a story problem on the homework?
I don't know.
I think there.
23,
No, wait, hold on.
No,
We don't have a 20.
B.
14 is a story problem.
Wait.
Does that make you do 20?
We can figure it out.
20 is not. Let's do
20 is not.
Let's
Do
figure
14.
Yeah, or it's just
14 together? Should we do it right now? Sure. We'll do a homework problem right now. All right, here we go. Anthony charges $15.
Yeah.
Yes. Yes.
Do we need graphs for all of these?
Maybe. I'm sorry. Do you want graphs right now?
Yes.
How about the graph paper Brady had?
Blah, 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 blah. Where are all my graphing papers?
They're on the bottom.
Did you guys know that Ella parts like an idiot?
I just got one off the
Ella
bottom.
parts like an idiot.
The bottom one. I just got one of these from right there.
She had the truck and it was parked like this when it's supposed to be this way.
Do you guys want these or the individual graphs?
Individual graphs.
I saw her pull in this morning and I watched her.
I don't have individual graphs.
You get what you get.
How many tries did it take?
I saw her back out like.
Well, I'm not as bad as Megan.
I don't have individual graphs. I'll give you individual graphs. Put your graph on the corner over here on the side, okay? For now, because I'm still recording. So I'll get you individual graphs here in a minute, okay? Number 14. Here we go. All right, are we ready? I mean, I don't have to do a homework problem with you, but if you want me to, I can. Okay. All right. Anthony charges $15 an hour for tutoring and $10 an hour for babysitting. Okay. He can work no more than 14 hours a week. Okay. How many hours should Anthony spend on each job if he wants to earn at least $125? Okay. All right. So he can work no more than 14 hours a week. So we have to be less than or equal to 14. But what is less than or equal to 14? Tutoring and babysitting. The number of hours tutoring plus the number of hours babysitting has to be less than or equal to 14. You see how that works? X and Y are the number of hours, okay? If you want to do T and B for tutoring and babysitting, that's fine too. We can do that. Yeah? Okay, now he charges 15 hours for tutoring and $10 an hour for babysitting. So if I want to figure out how much money I'm making total, I take 15 times how much? X, right? The number of hours that I do for tutoring, okay? Plus 10 times Y, because that's the number of hours babysitting.
So he wants to make greater than or equal to.
And at least 125. Greater than or equal to 125. You see how that works?
It's 5.
What?
It's 5.
What?
Huh?
They're 5.
Well, it can be.
It is.
knows the answers.
It could be.
know
It
the
could be
answer.
5.
It
5
is
and 5.
Put it in.
Well, but the answer is like a bunch of answers, right?
But it's
Like it could be 5 and 5, or it could be 5 and 6. I thought he spilled water over there.
Did you know how or what? But I will.
No, he's sitting on the edge like this.
All right, quit abusing my chairs.
But it's,
That was in my fault. That was
telling you,
all
you
Kellen's
plug in
fault.
5 and
Yeah,
you
he
get
just pulled-
125.
Sure. Yeah. That would work. Yeah, 5 and 5. Okay. All right. Now, 2 more things though. We're not done writing equations yet. We have 2 more things. We have another thing that involves X and another thing that involves Y. Is there a minimum amount? Like, does X have to be greater than something?
No, not technically. You don't have to do anything.
0.
Can you do negative though?
No.
Negative hours.
No.
Ah, so he has to be greater than or equal to 0, right?
Traveler.
And Y has to be greater than or equal to 0. Does that make sense?
No.
I'm going to say X is tutoring and Y is babysitting. So I have a thing here, okay? So I'm also going to add those 2 in there, that X has to be greater than 0, Y has to be greater than or equal to 0, right? Because we can't go negative hours in tutoring and babysitting, okay? All right, so that is part A, right? The system of inequalities to represent the situation. B, graph the system of inequalities and highlight the solution. Okay, so,
We need a graph.
I know, just put him off to the corner. I'll get you graphs here in a minute for all the other ones. Okay, so over here. Now, I'm only going to focus on the first quadrant because
But we can't go negative.
you can't go negative,
Widow.
right?
Do we have to, but we still have to graph those, don't we?
What?
The equations?
Mhm.
Yeah.
Oh, that's what we're doing.
So X is greater than or equal to 0 is this line right here, right? And he would be shaded to the right, right? Y is greater than or equal to 0 is this guy, and he is shaded above. You see how that works? So I can only have greater than or equal to 0 and greater than or equal to 0. So I'm in the first quadrant. Do you see how that works?
Wait.
Wait. Did you say wait?
I said widowy.
Oh, okay. All right, next. X plus Y is less than or equal to 14. Let's fix him.
Move the X over.
Move the X over. Minus X. So Y is going to be less than or equal to
Negative X.
negative X plus 14.
10 more.
Okay? I'm going to go by twos. 2, 4, 6, 8, 10, 12, 14. So I'm starting at 14, and then I go down
Down
I
1 over.
swear.
1 over 1, down 1 over 1, down 1 over 1. Where will he end up over here? If I go down 1 over 1,
14? No.
he'll end up at
14?
14 over there as well. Do you see how that works? If I'm starting up at 14 and I'm going down 1 over 1, I'm going to end up at 14 over there on the other side. Okay? Solid line or dotted line?
Solid.
Solid line.
Always.
And I want to shade below. I want to shade below. Okay? All right, we're going to have to work a little harder for this next one. I want to solve for y here. What shall we move? Minus 15x. Okay, minus 15x. All right, so we've got 10y greater than or equal to negative 15x plus 125. All right, then what?
Divide by 10.
Divide by 10. So y is greater than or equal to, let's reduce it. Reduce it. What's,
No, negative 3 halves.
yes. 15 and 10, I can divide by 5, so that's negative 3 over 2. X. And what's 125 divided by 10? 12.5. Okay, do you see where I'm at here? Right here in this equation? Okay. All right, so I'm going to start at 12.5. 12.5 is like here-ish. Really close.
My graph. You guys are work.
And I'm going to go down 3 and over 2. And I'm going to go down 3 and over 2, and down 3 and over 2, and down 3 and over 2. Oh, heavens. Where is he going to touch over on this side?
I'm not even like tracking. I don't think I'm graphing this right, but you can do.
Down 1, 2, 3, and over 1, 2. And down 1, 2, 3, and over 1, 2. So like here-ish.
Can we just say so like a 10?
Yeah. Yeah. Maybe. Ish. Something like that.
Yeah.
Something like that.
Are we done shading now? Are we done graphing now? Yeah,
Nope.
we are.
There's one.
No, we are.
Yes. Yes.
No, actually
On this part. Yes. Yes. Yes.
So
Yes.
we
Yes.
gotta graph the other one.
Yes. So this one is greater than or equal to. So what's like quadruply shaded? We had 4 equations. Which one is
The line-
quadruply shaded?
It's what's in between the two, like that one.
Any combination that's in between these two.
I couldn't talk about it.
Any combination in between those. Okay? That's my part B where we've graphed it, right? Anything in there will work.
Do I have to shade it in like that?
No. Just make them a little darker. Maybe.
Well, it has 4 colors. You got it.
Sure. Okay. All right, next. Determine whether 4, 5, 7, 6, and 5, 10 are viable solutions. Okay, I'm going to do it by using the equations, right? The first thing I need to check, well, I guess all of those numbers are bigger than 0, so I don't even have to worry about like these two things being okay. Let's check the first thing. Are those all, if I add them together, less than 14? If I add 4 and 5 together, is that less than 14?
Yes.
Yes, 7 and 6, less than 14? It's 13, so less than 14, it works, right? 5 and 10.
No.
The last one's not going to work, okay? So now let's check the first two, and let's make sure that we have like the 15x plus 10y. Is that going to be greater than or equal to 125? Let's check the first two equations and make sure that that works, okay? So if I plug 4 in here and plug 5 in here, 4 times 15 plus 10 times 50, this would be 60 plus 50. Is that greater than 125?
No, it's 110.
It's 110. That's not going to work, right? That's not going to work. Okay? Now let's plug in 7 and 6. 7 goes here, 6 goes here. What's 7 times 15?
I don't know. 7 is it 105? Yeah.
105. Yeah. 10 times 6 is 60. Is that going to be greater than 125? You betcha. Determine whether they are viable solutions. Give the constraints of the situation. So 7, 6 is the only one that works. Out of those, the other two do not. Okay? For different reasons. Right? How about that? That was quite a bit. Okay? All right, I will get you graphs. Anything else that we need to add?
Nope.
Okay, all right, there you go.
Our graph.
Goodbye, people.